ME8351 Manufacturing Technology 1 Unit for Sheet Metal Processes. In this video we are going to see the shearing, bending and drawing operations. Shearing operation. Shearing is the process of cutting a straight line across a strip. Shears are used as the preliminary steps in the preparing stock for stamping processes. Shearing has the three important basic stages: plastic deformation, penetration, fracture. Sheet metal operations are broadly classified into two categories: cutting operations and forming operations. First, sheet metal cutting, shearing. Yes, the fourth diagram shows how the shearing operations are to be occurred. In the first one, just before the punch contact work, is the lower part is the die, upper part is the punch, in between the sheet metal is placed, and the second diagram shows how the plastic deformation begins. And the third diagram shows how the penetration occurred in the sheet metals. And the final fourth diagram shows how the fracture can be occurred in the sheet metal by giving the external force in the punch against the die. The basic sheet metal operations are a cutting operation, bending operation, drawing operations. In cutting operations, shearing, blanking, punching, these three types of operation comes under the cutting of sheet metals. Bending and drawing is basically comes under the forming operations. Let's see one by one. First, cutting operation. In cutting operation, the workpiece is stretched beyond its ultimate strength and cut off into two pieces. First one of the cutting operation is the blanking. Blanking is the process of cutting a flat shape from the sheet metal. The metal that is punched out is called as blank, and the metal that is left out is called as the scrap. And the second operation in cutting is punching operation. In punching is the operation to produce circular holes on the sheet metal by a punch and a die. The metal punched out is removed as a waste. Yeah, the diagram shows the blanking and punching operation. First A, it's a blanking operations. The cutted out the scrap is the workpiece in the blanking operation. In punching operation, cutting piece is a scrap. And the next is the punching and piercing operations. Punching and piercing. A slug is produced in a punching operation but not in piercing work. Piercing is forming a hole in a sheet metal with a pointed punch with no metal fallout. In this case, a significant burr or deformed shape edge is created on the bottom side of the material being pierced. The two diagram shows the difference between the punches and the pierced object. And the next operation is the perforating, punching a number of holes in a sheet. And the next operation is the slitting. It is the operation of making an unfinished cut through a limited length only. And the next is the notching operation, removing piece from the edges. And the next operation is the parting, shearing the sheet into two or more pieces. This diagram shows the it's a perforating. It's a punching a number of holes in the sheets. Perforating, punching a number of holes in a sheet. This diagram shows a number of holes in a sheet metal. This operation is the perforating operations. And next is the slitting operation. Slitting is the unfinished cut through a limited length only. And next is the notching operation. It's removing the piece from the edges of the sheet metal. It remove the piece only in the edges of the sheet metal. And the next operation is the parting operation. It's a diagram show shearing the sheet into the two pieces by using the parting operations, cutting the sheet metal into the two pieces. And the next one is the launching operation. A hole is partially cut in a sheet and the cut material is bent without removing any material. It is a lancing operation. This diagram shows the first a sheet metal is cut and slightly bending to it. It is a lancing operation. Cut the sheet metal and slightly bending to it. And the next operation is the nibbling operation, cutting the irregular shapes using a small punches. This diagram shows the by using the small punches, cutting the irregular shapes in the sheet metal, punching a series of small overlapping slits or holes along the path to cut out a large contoured shapes. And the next operation is the trimming operation. It is the operation used for removing the excess material, the irregular outlines and waved edges from the walls of drawn shells or the surface of swaged and cast pots. Yes, the trimming diagram shows the it's remove the excess material from the product. The product is placed between the die and the punch. The excess material is removed by applying the force to the punch. And the next operation is the shaving. It is also similar to trimming operations, but here the amount of material removal is usually about 10% of the thickness of the blank. It's also similar to the trimming operation. It only remove the lesser amount in the sheet metal object. The shaving diagram shows the how the shaving operation is done. Here, shearing. Material thickness ranges from 0.125 mm to 6.3 mm. The dimensional tolerance ranges from plus or minus 0.125 to plus or minus 1.5 mm. Shearing process produces a shear edge burr which can be minimized to less than 10% of the material thickness. The major variables that affect the shearings are punch force, speed of the punch, lubrication, the hardness of punch and die materials, the corner radii of the punch and the clearance between the die and the punch. Is a force analysis in the shearing operation. Cutting force F is equal to shear strength into thickness into length of the cutting edge, that is F is equal to S into small t into capital L. Is a shear strength 0.7 ts into small t into L. Ts means ultimate tensile strength. For maximum force is used to determine the press for operations. And next one is the clearance between the punch and the die. What is clearance? Clearance is the intentional space between the punch and the die cutting edges. It is a gap or space between the punch and the die cutting edges. The diagram shows a D, capital D is the dies. Above the dies, it's a block named as the P. It's a punch. The gap between the punch and the die is two gaps, left and right one. It's a clearance C. C by 2 means clearance in the both side, left and right. Clearance C is equal to D minus D1. Therefore, clearance per side C is equal to C by 2. Clearance by 2. Generally, clearance is of 5 to 10% of the material thickness. Here's the formula to find out the clearance. C by 2 is equal to 0.01 into material thickness into shear stress. This is the clearance and its effects. Greater clearance, that means rough cut formation of burr, material is pulled rather being cut. For smaller clearance, good cut edges, force required is more, tool withdrawal is difficult. Yes, the diagram shows how the clearance is to be given to the punch and the dies. It's the effect of the clearance. And the next operation is the sheet metal bending operation. What is sheet metal bending? The metal on inside a neutral plane is compressed while metal on outside of neutral plane is stretched. Yes, the diagram shows it's a strip. The central line is the neutral axis. The inner line is the metal compressed range and the outer one is the metal stitching area. The material is stretched behind the yield strength but below the ultimate tensile strength. The surface area of the material does not change much. Bending usually refers to the deformation about one axis. Here is the bending. is the bending processes. The metal is stretched beyond its elastic limit. This diagram shows the where is the expansion, compression, and the neutral axis are. First is let's see the diagram. Here is the straight line is a sheet metal. When due to its bending operation above the neutral line, it's a expansion, and below the neutral line is the compression. The line in which there is no changes in length is called neutral line. The layer above the neutral line are stressed by tension, but the layer below this neutral line are stressed by compression. Here some of the bending operations are: operation of forming the metal between a suitably shaped punch and the forming block. The inclined angle on the tool is usually smaller than that to be produced to allow for the spring back of the material after forming. What is the spring back? Is the term which denotes the property of sheet metal to partially fall back from its bent position when the punch retards after completing the operation. As the diagram shows the as a spring back of the sheet metal effects. Reason for the spring back is the bending pressure is removed, elastic energy remains in the bent part, causing it to recover partially towards its original shape. Types of bending operations: first, the angle bending, roll bending. The various bending operations are displayed in the diagram. First one is the channel bending, U bending, air bending, offset bending, circulating, tube bending. First one is the angle bending. In this case, metal is bent at an angle to each edges. It is denoted by a theta. If the theta is lesser than 90 degree on side, it is called a single bending. If theta is equal to 90 degree, this is called as a vertical or straight bending. If the theta is greater than 90 degree but in two places on the same work, it is called double bending. And the next bending operation is the roll bending. Yes, the diagram shows the roll bending, how the sheet metal is to be rolled. If the material is bent in the form of rolled edges at the edge of the work, it is called roll bending. And the next operation is the roll forming. If the edges are formed to a desired shape or any impression in the form of bend is made on the sheet metal, it is called as the roll forming operation. And the fourth one is the seaming. The process of providing the lock between the two edges of the different work material is called seaming. The diagram shows how the two sheet metal has to be interlocked by the seaming operation. Cap strip stream, locked corner stream. These are the two diagrams displayed. To perform this, the edges of the sheet metal to be locked or bent in opposite direction to each other. Then they are inserted with each other and pressed or tightened to make a complete the lock. Here is the some of the types of sheet metal bendings are: the basic bending operations are V bending and edge bending. V bending performed with the V-shaped die. The diagram shows the The die is made up of V shape and the punch also in the shape of V. Between the punch and the die, the sheet metal is placed. The force is given to the punch gradually. The V bending operations are to be done. For low production performed on the press brake, V dies are simple and inexpensive. And the next one is the edge bending, performed with a wiping die. For higher production, pressure pad required. Dies are more complicated and costly in edge bending. It's a diagram shows the edge bending operations with the using the wiping die. And the next one is the third category of in this particular topics. We are already discussed about the shearing operation, bending operation, and the final one is the drawing operations in the sheet metal. Drawing operation consists of a punch forcing a sheet metal blank to flow plastically into the clearance available between the punch and the die surfaces, and the die surfaces so as to acquire an up shape, a cylindrical shape or a box shape. Is the simple diagram shows the drawing operations. The sheet metal is placed between the punch and the die. A box shape or cylindrical shape are is to be formed in the drawing operation. Drawing a cup shaped part before punch contact work. Next, types of drawing operations. First one is the deep drawing. The length of the part to be drawn is deeper than its width. Deep drawing is the manufacturing process of forming sheet metal stock called blanks into geometrical or irregular shapes that are more than half their diameter in depth. In the simple definition, the length of the part to be drawn is deeper than its width. That is called deep drawing. This diagram shows the deep drawing operations. It's a The length of the part are to be drawn is deeper than its width. The common shapes for deep drawn product include cylinders for aluminum cans, cups, and baking pans. Fire extinguisher, kitchen sinks are also commonly manufactured by the deep drawing method. Limiting drawing ratio LD or DO by DP. Maximum blank dia and the punch dia determines the largest blank which can be drawn. The maximum value of LDR is 2.7. And the second operations in drawing is the shallow or box drawing. In this case, the length of the part to be drawn is lesser than its width. It's a vice versa of the deep drawing. Example: seamless pots, tubs, cans, and covers, etc. Thank you.